Hello, geometry classes. Welcome to a new chapter. So we're going to be taking a look at chapter 11, and we're going to start by looking at how we can find the lengths of circumferences of circles and their arc lengths. So we've got we've got one theorem and one corollary that we're going to be working with in this lesson. The first theorem is probably information you're familiar with, and that is the formula for a circumference of a circle. And there's two formulas that we use when we're finding the circumference of a circle. One is C, circumference, is equal to pi d, where d is the diameter. If we know the diameter and want to find the circumference, that's going to be the formula we'll choose. But if we know the radius, we would use the formula C equals 2 pi r. Remembering that the diameter is always twice the radius, which I've noted over here underneath our circle. We can go back and forth between the radius and the diameter easily. If we know the radius, double the radius to get the diameter. If we know the diameter, divide the diameter by 2 and you'll have the radius. So where does this formula come from? Well, here it is. It's a very simple idea to get from the definition of pi, which is the ratio of the circumference of a circle to its diameter, and that's a constant value, approximately 3.14 or pi. If we multiply both sides of this equation, which is the definition of pi, if we multiply both sides of the equation by d, we get the circumference of a circle formula, c equals pi d. And then to go from c equals pi d to 2 pi r, we replace the diameter, d, with 2 times r. There's our 2 times r, and the pi remains. Now, when we are finding circumferences of circles, we are going to round our values to the nearest hundredth unless we're told otherwise. Okay, the second piece of information that we're going to use in this lesson is a corollary. It tells us how to compute arc length. So if we wanted to find out how long it is from A to B, how long a piece of string would we need to get from A to B, what we will do is we'll find the measurement of arc AB, that would be whatever the central angle is here, and compare that to 360. So the number of degrees of arc AB to 360, a full circle number of degrees, that will be equal to the arc length of AB, this length here, the red piece, to the circumference of the circle, 2 pi r. So we're comparing the part to the whole. The part of the circle that is red, its arc measurement, to the total number of degrees in a circle, 360. And that will be equal to the ratio of the arc length of AB, the little piece of the circle, to the entire circumference of the circle, 2 pi r. Okay, so we've got our theorem and our corollary. Let's go ahead and work through some examples and guided practice problems. Example 1, we're asked to find the circumference of the circle, knowing its radius, which is 9 centimeters. So we'll start with our formula, c equals 2 pi r. Since we know the radius, we'll choose the formula c equals 2 pi r. And then we'll replace the radius with 9 because we know what it is. And then we'll multiply the 2 times 9, so the circumference is 18 pi. At this point, once we've done the simplifying that we can, we'll use a calculator to determine the value. You may use 3.14 for the value of pi. Some of your calculators will have that value in, which is a little more accurate. So some of your answers might not match the values that you're seeing in the answer key exactly, depending on whether or not you're using 3.14 for the value for pi or the pi button on your calculator, which will be more accurate. As long as you're close to the values that are given, you will be good. So using our calculator, rounding to the nearest hundredth, we get 56.55 hundredths centimeters for the circumference of the circle that has a radius of 9 centimeters. Part B of example 1, we're asked to find the radius of the circle, knowing its circumference is 26 meters. So again, we're going to use the formula c equals 2 pi r. We'll put in 26 for our c. 26 is equal to 2 times pi times r then. Then we're going to divide both sides by 2, and we'll have 13 equals pi r. And then we'll divide both sides by pi. R is equal to 13 over pi. At this point, plug it into your calculator, round to the nearest hundredth, and you'll find that the radius is approximately 4.14 meters. Guided practice 1, we're asked to find the circumference of a circle, this time knowing its diameter. So we'll use the formula c equals pi d rather than c equals 2 pi r, since we know the diameter of the circle. So we'll put in 5 for our d, and then we'll use our calculator and round to the nearest hundredth, and we'll have circumference of that circle is 15.71 inches. What happens if we want to know the diameter of this circle, knowing its circumference is 17 feet? Pick the same formula. We know the diameter, so we can we want to know the diameter, so we're going to use C equals pi d because we can plug in the circumference. So put 17 in for C because that's what we were told the circumference was. And then solve it for d, divide both sides by pi. Use a calculator at this point. 17 divided by pi gives you approximately 5.41 feet. Okay, guided practice 2 takes us into a real life example. Let's say we have a tire that has a diameter of 28 inches. I've drawn a representative view of this tire with a diameter of 28 inches. And the question is, how many revolutions does this tire make traveling 500 feet? So we have to imagine it's rolling out on the street surface, and each time it rolls one full revolution, it has covered a distance of the circumference of that circle. So we need to know, for our 500 feet, how many circumferences are there in that 500 feet. Well, our first step is to notice that we have both feet and inches as our units. We were given the diameter is 28 inches. We were asked to figure out, for that tire traveling 500 feet, how many revolutions does it make? Well, we'll want to first change that 500 feet into inches so our units are the same. So since there are 12 inches in every 1 foot, 500 feet times the 12 inches will tell us that 500 feet is the same thing as 6,000 inches. Now, let's calculate the circumference of one revolution of the tire when it goes around once. So that circumference will be equal to pi d. We're given the diameter. That's why we're choosing this formula. Circumference is pi times 28, since the diameter is 28. Our circumference is approximately 87.92 inches. All right, so we're going to use that information now and set up a ratio to solve the problem. 87.92 inches per one revolution is equal to, or is the same thing as, 6,000 inches, which is our total number of feet, 500 feet, 6,000 inches. That compares to however many revolutions that tire can make. So we're going to go ahead and add in here, this kind of got dropped off, 87.92. 87.92 n is equal to 6,000. 6,000 times 1 is 6,000. We're using our cross products here, 87.92 times n. Okay, then we divide both sides by 87.92, and using our calculator, we'll get a value slightly higher than 68. But it doesn't make any sense to talk about revolutions in parts, so we're just going to report our answer as approximately 68 revolutions. Makes slightly more than 68 revolutions, but 68 is close enough because running off to the nearest whole number makes sense in this application. Okay, guided practice 3. What is the length? How long is it from P to Q? So here we're going to use our ratios of part to whole, and we're going to compare the PQ length, however long it is, to the entire circumference of the circle, P times 9, pi times 9 that is, and that's going to be equal to the 75 degrees, that's the arc measure in degrees, to the entire number of degrees in the circle, 360. So we're comparing our part to our whole. So length, the part length to the whole length is equal to the part number of degrees to the whole number of degrees in the circle. So we're setting up ratios to be able to express our relationships to solve for our unknowns. All right, well, the first thing I'm going to do is I'm going to do some simplifying. I'm dividing both of these by 3, and I arrive at 15 over 72. And then I notice I can divide both those by 3 again. And so PQ over 9 pi is equal to 5 over 24. At that point, I'll use cross products. 24 times PQ, that arc length, is equal to 5 times 9p. Again, we're simplifying. I'm going to divide both sides by 24. 5 times 9 is 45. And I notice I can reduce 45 over 24 to 15 over 8. And at this point, I'll use my calculator. I've done all the simplifying that I can do. And so I'll plug in 15 times pi divided by 8, and I'll arrive at 5.89 yards to the nearest hundredth. All right, what about the circumference of our circle here? Given the information that we have the big angle here, 270 degrees, that's the red arc here. And we're also told that the red length here is 61.26 meters. So again, using part to whole, the 61.26, which is part of the circumference of the circle, compared to the entire circumference of the circle, is equal to 270 degrees, and that is the measurement for this red arc to the entire circle of the circle of 360 degrees. Okay, so using cross products, not quite yet. We're going to go ahead and reduce where we can. 270 over 360 first, divide by 10 over 10 and get 27 over 36. Then divide your 27 and your 36 by 9 and you'll have 3/4. So 270 over 360 reduces to 3/4. Then I'm going to go ahead and use cross products. 3 times c equals 4 times 61.26 for my cross products. Divide both sides by 3. Use a calculator at this point. And then I run to the nearest hundredth, and my circumference would be 81.68 meters. Last guided practice problem. What is the radius of the circle that you see here? We are told for this circle that this red arc here is 150 degrees. We are told that its length is 10.5 feet. We'll use our part to our whole relationship once again. And so the 10.5, which is part of the length of the entire circle, compared to the circumference of the circle, 2 pi r. We don't know our r yet, but we know to figure out the length of that circumference, we would use 2 pi r. Well, that's equal to the part of the circle we're interested in, the 150-degree arc here, compared to the entire circle, 360 degrees. Okay, so first thing I'm doing is I am reducing this fraction 150 over 360. First I divide by 10 over 10, and I get 15 over 36. And then I divide by 3 over 3, and I have 5/12. So 150 over 360 reduces to 5 over 12. And then I'm going to use cross products. 5 times 2 pi r, that's this left-hand side, is equal to 10.5 times 12. And then my next step is dividing both sides by 5 times 2 times pi, and since 5 times 2 is 10, I'm going to be dividing by 10 pi. I'm going to leave the 10.5 times 12 in the form that it's in. Then I'm noticing that it would be easy for me to reduce the 12 over 10 to 6 over 5. And then I'm noticing that it's easy to divide 10.5 by 5. 5 into 10 goes twice, 5 into 0.5 goes once, so 10.5 over 5 is 2.1. Then I'm noticing it's easy to multiply 2.1 times 6, that's going to give me 12.6, and 6 times 2 is 12, 1 times 6 is 6. And at this point, I'm going to use my calculator. 12.6 divided by pi gives me 4.01 feet for the radius of that circle. That concludes our guided practice problems for lesson 11.1, so now it's time to move on to the homework portion, and we'll see you next time.